Welcome to Learning Simplified. Today's topic is going to be about engine cooling systems. So now let's have a look at the basic components involved in the engine cooling system. The main objective of the engine cooling system is to maintain this engine block at its operating temperature. In order to do so, the engine block consists of a water jacket. The water jacket is nothing but a passage for the coolant to flow around the engine without interfering into the combustion chamber. The next component is the water pump. The water pump is a device which is used to circulate the coolant in the cooling system. The water pump consists of an impeller on one side and a pulley on the other side. The pulley and the impeller is connected with a common shaft, which means that once the pulley rotates, the impeller also rotates. The pulley gets its drive from the serpentine belt or the alternator belt of the car. In some cars, the water pump is driven by the timing belt. The next component is radiator. The radiator is made up of small capillaries through which coolant can flow, and in between these capillaries there are fins through which air can flow. So once air flows through these fins, it cools the temperature of the coolant in these capillaries. The radiator consists of the radiator fan, a radiator cap. The radiator cap has a spring valve attached to it, and this spring valve helps to reduce the pressure buildup which happens in the cooling system. The next component is the coolant expansion tank. The coolant expansion tank plays a role when the pressure inside the system is being reduced. Then comes the thermostat valve. The thermostat valve helps in regulating the pressure inside the cooling system and also in maintaining the engine at its operating temperature. The coolant temperature sensor is an electrical probe which is inserted into the coolant pipeline. This coolant temperature sensor sends signals to the ECU regarding the current temperature of the coolant. So now let's have a look at the pipe connections of the engine cooling system. Okay. This is the water pump outlet hose, and this is connected to the water jacket's inlet port. And this is the water jacket's outlet port which is connected to the thermostat housing. And this is the thermostat bypass valve. And this is the radiator upper hose. This is the radiator lower hose. And this is the bleed expansion hose. Okay. The function of the engine cooling system can be divided into two phases. The first phase is helping the engine attain its operating temperature at the least possible time. The next phase is maintaining the engine at its operating temperature. So now let's have a look at a cold engine. Once the cold engine is started, so the water from the water pump outlet hose goes to the water channel inlet, and through the engine's water channel outlet it comes to the thermostat valve. Here the thermostat valve sends the coolant into the thermostat bypass hose back to the water pump. During this pattern of circulation, the coolant does not enter the radiator, so there are no chances of the fluid getting cooled. So all the heat which is generated during the engine combustion is absorbed by the coolant, and the coolant also heats up, and so does the engine. So the engine attains its operating temperature. So once the engine has reached its operating temperature, and the temperature of the coolant just increases a little above the operating temperature, the thermostat valve opens. So once the thermostat valve opens, the coolant is sent through the radiator upper hose into the radiator, and from the radiator the coolant is returned back to the water pump through the radiator lower hose. So as the coolant flows through the radiator upper hose, the coolant temperature sensor senses the temperature of the coolant and sends the signal to the ECU. So the ECU acts accordingly, either by switching on the radiator fan or by regulating the speed of the radiator fan based on the coolant temperature. So once the coolant enters through the radiator upper hose, the coolant temperature sensor senses the temperature of the coolant and sends the signal to the ECU. And then the ECU switches on the radiator fan. So when the radiator fan is switched on, it sucks atmospheric air, and this air passes through the radiator fins. So when it passes through the radiator fins, the coolant in the capillaries of the radiator is cooled down. So the coolant with the lower temperature is sent back to the water pump. Now that the coolant has been circulating at a high temperature, there is also a pressure buildup which happens in the system. In order to reduce this pressure buildup, the spring valve which is attached to the radiator cap opens. So once the spring valve opens, the coolant is pushed into the coolant expansion tank. So once when the coolant is pushed into the coolant expansion tank, the pressure in the system reduces. And as a result of which, there is a vacuum also which gets created in the system. And due to this vacuum, the coolant is again pulled back into the system. So this is the reason why the coolant in the coolant expansion tank should not be more than the maximum level marked in the coolant expansion tank. So during this operation, when the coolant temperature has just dropped below the engine's operating temperature, the thermostat valve closes and the coolant is passed through the thermostat bypass valve. So this is how the engine cooling system works. I hope this video was informative to you. For more such videos, please do like and subscribe to my channel. Thank you.